In previous lectures, we discussed the first law of thermodynamics and some of its applications for isochoric and for isobaric processes. We showed that when a process takes place under isochoric conditions, that is, at constant volume, the heat is equal to the change in energy delta U. We then introduced the thermodynamic function H, called enthalpy, and indicated that under isobaric or constant pressure conditions, the heat associated with any process is always equal to the change in enthalpy. In our last lecture, we applied this concept to the case of phase transitions. Over the next 3 lectures, we will turn our focus onto chemical reactions. Very much like phase transitions, chemical reactions occur under isobaric and isothermal conditions. So our calculations of work, heat, change in energy will follow a very similar path to what we have done with phase transitions. The main difference between phase transitions and chemical reactions lies in how we obtain the standard enthalpy change for the process, delta RH standard, where R stands for reaction. In short, we will call this the standard reaction enthalpy. Today, we will start our discussion of heats of reactions, standard reaction enthalpy, and standard reaction energy. We will see that there is a number of ways to get at standard reaction enthalpies. The first method we discuss today is an experimental approach that relies on bond calorimetry. The second method makes use of bond enthalpies and mean bond enthalpies. In our next lecture, we will discuss the last 2 methods based respectively on Hess's law and on the use of formation enthalpies for individual substances. These methods were introduced in general chemistry, so most of the material covered in this and next lecture should be familiar to all of you.